right, so here we are with chapter 24, the last chapter that we're covering in this course. I feel sorry that we're doing this one in particular in this manner because I had what I thought were some nice activities scheduled around volume and polyhedra and making shapes in class. That is a fun activity also to extend to future students. So I will try to incorporate a tiny bit of that, but obviously it won't be the same. So what do we mean by area? What do we mean by surface area? How are the two things the same and how are they different? Well, you'll see a little bit more when I show you some nets later. But when I talk about area, I'm talking about any kind of flat space, right? Length we measure in one dimension, area we measure in two dimensions. And volume, which we'll get to later, we measure in three dimensions. All right, that's area, like this. Surface area is essentially just area that is wrapped around a shape. So if I had a cube like this one here, each side has its own area, and I can measure each of those areas. Well, if it's a true cube, they should all be the same, so I could just measure one. But it's really just an area that is on the surface of a shape that we're interested in. And I will talk about that a little bit more in the nets, perhaps. So as with other measurements of length, we can have standard or non-standard units. The standard units for area include things like square meters. That's how I would say that, not meters squared. Square centimeters, square feet, square inches. A square meter is just a shape. The basic idea is a shape that is 1 meter along each side of a square, or any equivalent amount of area that's covered. So for example, something that is 1/3 of a meter by 3 meters would also be 1 square meter. Or I could take a triangle off one side and add it on to another side to get a shape that looks like this, that would also have an area of 1 square meter. So when I say a square meter, it doesn't explicitly say that the shape is a square, but it's equivalent to the amount of area covered by a square that is 1 meter on each side. Now, if I know that there are 10 decimeters in each meter, then how many square decimeters are there in a square meter? So I'll take a moment to draw this. Here's a square meter. And I'm going to break this up into 10 decimeters. All right, so I've done this off screen and I have indicated that each side here is divided into 10. So if this is 1 meter on each of the 4 sides, then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decimeters. And hopefully I did it the same way on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 decimeters also along that side. So how many square decimeters? This, assuming that my drawing were perfect, this is 1 square decimeter. And so should this be. and this, and so on. How many of these do I have in a shape that's 10 by 10? I have 100 of them. So 1 square meter is 100 square decimeters. Okay, how many square centimeters are there in a square meter? Well, there are 100 centimeters in a meter. So if I can break this into 100 on this side and 100 on this side, I'm not going to try to draw 100 lines, but I would have 100 times 100 square centimeters in here, which is 10,000. So 1 square meter is 10,000 square centimeters. What about millimeters? I don't know if we still need the drawing at this point, but there are 1,000 millimeters in a meter. And so there are 1,000 times 1,000, which happens to be 1 million, square millimeters in a square meter. So 1 square meter is 1 million square millimeters, and so on. I won't do all the rest of these right now. Maybe I'll do one where the area is getting smaller, and then I'll fill the rest in before I post this. So how about we do how many square kilometers there are in a square meter? Well, there are 1,000 meters in 1 kilometer. So if I reverse that and divide each by 1,000, in 1 meter is 1,000th of a kilometer, or 0.001 kilometers, or scientific notation is handy for this, 1 times 10 to the minus 3 kilometers. So instead of having a square that has multiple units along each side, it has a fraction of a unit along each side. In other words, this is 0.001 kilometers, and this is 0.001 kilometers. And the area in square kilometers So this works out to, well, I can count the number of zeros, or I think I kind of like doing it with scientific notation. So 1 times 10 to the minus 3 times 1 times 10 to the minus 3 is 1 times 10 to the negative 6. So 1 square meter is 1 times 10 to the negative 6 square kilometers. And that means that just as there are 1,000 meters in a kilometer, there are 1 million meters in a square kilometer. A common task is converting between units of measurement, not necessarily 1 square meter, but a measurement like 5.7 square hectometers. And I'd like you, rather than memorizing specific numbers for square meters and cubic meters and so on, I'd like you to understand and use those relationships that we were just talking about. So for example, 5.7 square hectometers, 100 meters is 1 hectometer. So I have two potential ways of doing this. I'll do it first like I did above. We could find a value for hectometers first. So if I know that a hectometer is 100 meters, then 1 square hectometer is an area that's 100 meters by 100 meters. If it helps you to draw it, you're certainly welcome to do that. You have 100 meters by 100 meters. And that area is going to be 100 times 100, which is 10,000 square meters. And now, I wasn't asked for 1 hectometer square, 1 square hectometer. I was asked for 5.7 square hectometers. Well, that's 5.7 times, instead of a hectometer, a square hectometer, I'm going to have 10,000 square meters. So this is 57,000 square meters. Now, if you recall last video, I said that I particularly like this method called the factor label method. And we can still use that here even when we have square meters. So let me do the same question using the factor label method. I have 5.7 hectometers. Let me just make that 5 clear. 5.7 hectometers, square hectometers. And I know that 1 hectometer is 100 meters. So I can use this conversion factor of 1 hectometer over 100 meters, or 100 meters over 1 hectometer, and those are both equal to 1. So I could multiply by that. So 5.7 square hectometers times, well, I want to be able to cross out hectometers, so I want to use this one where they're in the denominator. So times 100 meters over 1 hectometer. Notice that I have 2 hectometers here. I have hectometers times hectometers. So when I cross out this one, I'm really only crossing it out with the 2 here, because I've only eliminated one of them so far. So in order to eliminate the other one, I have to multiply by that same factor again. And now I'm left with 5.7 times 100 meters times 100 meters, which is indeed 57,000 meters. Same answer as above. I apologize, meters squared. Same answer as above, but done using the factor label method. So the factor label method can be extended to situations where you have more than one copy of a unit, where you have more than one dimension, essentially. Now, this was originally conceived as a group exercise, but what I will do is leave it as an exercise for you to do at home, and I will fill in the answers in the copy of these that I post online afterwards.